Some series to integral calculus. Some series to integral calculus, the arena in which we are making the discussion. Okay, some series into integral calculus. We will take other series also. We will try for the kind of reverse manner if it is possible, like Taylor series expansion of logarithmic or sinusoidal and whatsoever. And then from the series, can we bring the reverse function against, because Taylor series talks about the summation of series only. If it is logarithmic of 1 plus x, then it will be something plus something plus something. So can something plus something plus something can be brought into back to the Taylor expansion. So this is what we will see. But anyway, we are pursuing the discussion. We are pursuing the discussion in the Grandi series. This is what we are we are pursuing the discussion in the Grandi series, and this is what we are doing. So, Grandi series, when we talk about the Grandi series, two episodes we have made. Two times we have discussed about the Grandi series. Very, I would rather say unexpectable result anyone would see from the Grandi series. That is 1 minus 1 plus 1 minus 1 plus 1 minus 1 up to infinite will give 1 by 2. Can someone imagine on it? This is my question to anyone. If I write 1 minus 1, then it is 0. If I write 1 minus 1 plus 1, then it is 1. Then no. Then I say minus 1 is at the end, then 0. No. 1 is at the end, then 1. But if someone compute 1 minus 1 plus 1 minus 1 plus 1 like that to infinite, it will come 1 by 2. This is something I'm 100% sure no one would have expected. That's why this series called Grandi series, and it is very famous. Grandi series. So in Grandi series, we will talk about other two way in successive approximation in integral calculus to calculate the Grandi series. What are the two ways? We are calculating the summation of a series through integral calculus. Integral calculus works in area manner. How integral calculus works is someone has to calculate the area. Okay, what is the area, what is the integral calculus, and those things I will demonstrate again before we proceed. Okay, the concept is that whenever we try to solve anything through any technology. Okay, because in the book, in the examination, in front of a student, in examination, in the front of a student, it is written as 1 minus 1 plus 1 minus 1 plus 1 dot till infinite. What is the summation? That you have to calculate. If someone goes through normal algebra, then s equal to this much, 1 minus s equal to this much only, 1 minus 8 equal to s, 2s equal to 1, s equal to 1 by 2. This is what someone would prove. But if I try to prove it through integral calculus, then calculus has its own technology. And in that technology, there are two components, because integral calculus is nothing but calculating the multiplication through area graph. If I have to calculate multiplication of two items, then two items will be drawn in graph. Like if I say 5 into 4, then 4 will become 4 x-axis and 5 will become y-axis. Two operand of a multiplication will become two axes in xy plane. One is x-axis, one is y-axis. Now draw the graph. Whatever graph, if this is x-axis and 0 to 4, then this is y-axis 0 to 5. Draw the graph. Means if x is varying 1, 2, 3, 4, y is always 5. So it will make a rectangle of height 5, width 4. What is the area of this rectangle? 20. Means 5 into 4 equal to 20. This is integral calculus. Whatever multiplication someone has to calculate, then two operand of multiplication will become two axes, one x-axis and y-axis. Against x-axis, draw the y-axis as a graph and calculate the area, that is your multiplication. Like if I say I have to multiply x into x, x into x, then right hand side x is x-axis where it goes from 0 to x. Left hand side x is y-axis. Since it is x, x means x, it should be other than x. If I multiply two items, 5 into 4, 5 is different, 4 is different. Or if I write 5 into x, then 5 is different, x 5 is different, and x is different. But if I write x into x, then y-axis is x, x-axis is x. Means y-axis is height, x-axis is width. As we move along width, along x-axis, height is changing. Means height is variable or dependent upon x. X into x can be rewritten as function over x into x, can be rewritten as function over x dx, limit 0 to x. Means multiplication x into x changed into function over x into dx, limit x 0 to x 0 to x. Means x will go 0 to x, and y, that is vertical, at different x, what is the vertical? At different x, the vertical will keep changing. When x is 0, vertical is 0. When x is 5, vertical is 5. When x is x, vertical is x. It will make a slant straight line. Okay, underneath, what is the area? That area is nothing but x into x. Makes sense? This is where integral calculus comes into the picture. Area calculation by drawing the graph where two axes are the operand of multiplication. Means, are you trying to find multiplication through integral calculus? Yeah, integral calculus, indeed, it calculates multiplication of two operand only, nothing more than that. But these two operands are drawn in a graph calculating the area, and that area we say this is your multiplication. If that area is a rectangular area, then it is a constant normal multiplication. If it is not rectangular, then it is not normal multiplication. Like sin x into x, I cannot write an x sin x. Wrong. Sin x into x will become sin x dx. Actually, the area will come as cos x. So multiplication is cos x. From x equal to what to what? Makes sense? I believe this is understandable. So integral calculus calculate the area. If I am trying to find the sum and series through integral calculus, we are the first people who are trying to find summation of a series through integral calculus. Otherwise, it is not available in any of the book. That summation of a series can be achieved through integral calculus. Okay, in that fashion, we will try for the Grandi series. We have tried two times. We'll try third time also. Grandi series. Now, if this is x-axis, against x equal to 0, okay, Grandi series, let's start at x equal to 1. So x equal to 0, we are not considering. When x equal to 1, I have a function over x that is vertical is 1. When x equal to 2, I have a vertical that is minus 1. X equal to 3, I have a vertical called 1. X equal to 4, I have a vertical of minus 1. X equal to 5, I have a vertical of 1. X equal to 6, I have a vertical of minus 1. Like so. Means I have vertical of 1, 1, 1 at odd number of x. X equal to 1, x equal to 3, x equal to 5, x equal to 7, and so on. I have minus 1 at x equal to even number. X equal to 2, 4, 6, 8, and so on. Okay, means when x is even number, then I have minus 1 as function over x. When x is odd number, function over x is plus. Makes sense? If I want to calculate the addition of it, let's segregate into two parts. Let's segregate into two parts. First part is where x is odd number, and second part is where x is even number. Odd number, even number. Okay, if that is the case, Then against odd number we have x equal to 1, 3, 5, 7. Against even number x equal to 2, 4, 6, 8, and so on. Value function over x at any x is minus 1, and in odd number function over x at any x is 1. Okay, so that is what it is. If I tackle only odd number right now, then x equal to 1, height is 1. X equal to 3, height is 3, height is 1. X equal to 7, 5, height is 1. X equal to 7, height is 1. In that manner, now this is, if I connect all the top point, if I connect all the top point, then it will be a flat line. Okay, it will be a flat line where x equal to 1, height is 1, x equal to 3, height is 1, x equal to 5, height is 1, x equal to 7, height is 1. If I connect all the top point, it will be flat line. This line I can call it fx, function over x. Function over x equal to 1 irrespective of any x value. What we are trying to calculate, the odd number summation. Summation x equal to 1 to n, where x is n. Function over x, where x is jumping 1 1. Means if I say summation sigma sign, summation x equal to 1 to n, function over x I can rewrite as function over x plus function over x plus function over x, like so and so, where x is 1, x is 3, x is 5, x is 7, and so on. Okay, last is x is n. Someone can say n tends to infinity, but x is n. Okay, what is function over x? 1, 1, 1, 1. Everywhere it is 1. Okay, now if I want to introduce integral calculus, I have to come through area manner. Consider that this is fx. Fx is a flat line, that we understood. This is fx, and fx is a flat line. If fx is a flat line, then we consider another function called gx. There is another function called gx. If this is another function called gx, it is a continuous line, where fx, the flat line of height 1, is a discrete line. It is sampled at x equal to 1, 3, 5, 7. It is not a continuous line. It was made, it was constructed by touching all the top point. Then it become a line. If I go through a gx, there is another function called gx, and gx is a continuous line. Gx is a continuous line. What is this line is, when we have x equal to 1, I have fx as 1. Can this fx be same as the area between 1 and 3? Next vertical is at 3. X equal to 1, I have one vertical in fx. X equal to 3, I have another vertical in fx. X equal to 5, I have another vertical in fx, like so. Between two vertical, can we draw one area strip and then it goes and hit gx? Means limit x equal to 1 to 3 gx dx, that area will be exactly same as left hand side what we have fx now. What do you mean? Next area will go from x equal to 3 to 5. Limit x equal to 3 to x equal to 5 gx dx. This area, this area will be exactly same as left hand side, that is x equal to 3 fx, that is 1. Means everywhere the 2 gap, x between x to x plus 2 gx dx, x equal to x to x equal to x plus 2, this gx dx, this area will be exactly same hand left side fx, that is 1. Like this, if I do, the last vertical is x equal to n. Last area will be n to n plus 2. So if I have n number of, though not we don't have n number of vertical, but if I have n number of vertical, imagine against each vertical I have a sub area. Makes sense? I am saying sigma x equal to 1 to n fx equal to limit x equal to 1 to 3 dx dx plus x equal to 3 to 5 dx dx plus x equal to 5 to 7 dx dx plus last will be x equal to n plus 2 gx dx. we have already seen it, where each sub area has a width of 2, x equal to 1 to 3. Can we take left hand side area? If this is the right hand side area, can we take left hand side area? Means when x equal to 1, I have fx as 1, and that should be same as area from 1 to 1 minus 2, this area. If I take if I take x equal to 3, then fx is 1. This 1 should be same as area from x equal to 3 to x equal to 1, left hand side area. Then last area will be n minus 2 to n gx dx. Okay, means whatever vertical we have in fx, all vertical will correspond to area on left hand side of width 2, that will go and hit gx. In that manner, addition of all the vertical will be same as addition of all the sub area. Means if I know gx, then begin to end integration will give the net addition of all the vertical. Perfect. Okay. We'll try left hand side. Means if I have fx at x equal to limit integration x equal to x minus 2 to x gx dx, left hand side, x to x minus 2 gx dx will be same as at x, what is fx, same for others. Now we will try to find gx in this manner. This is what the discussion we have started. So in this manner, gx will come as, this manner, gx would come as fx equal to gx dx, dx equal to dfx by dx. Fx is 1, so it will come as 0. We will start with 0. Gx is 0, dx, result will be 0. Here we want 1, we are getting 0. Successive approximation. We will now approximate new. So dx we had taken 1 and 0, it did not work, where required is 1. So we will add by 1, we'll try with 1. 1 dx. Integration will be x minus 2 to x. It will come as 2. This side we have 2, this side we have 1. So now we have to, someone will say subtract by 1. Okay, we will divide by 2. So we had taken 1, we will divide by 2. 1 by 2 gx we will take. 1 by 2 dx, 1 by 2 x. X minus 2 to x, that will come as 2 by 2, 1. Perfect. So we have got the gx, and gx is 1 by 2. Now what will be the net addition of all the vertical? Now vertical is at x equal to 1, that is 1, x equal to 3, that is 1, x equal to 5, that is 1, x equal to 7, that is 1, and so on. If these are the verticals, then if I add all the sub area, because each sub area corresponds to vertical is at x equal to 1, then it corresponds to sub area between x equal to 1 to x equal to minus 1, this sub area. Means if I calculate the full integration, then lower limit will be from minus 1 and highest limit will be up till n, because nth sub area is from n to n minus 2 up to n, and this is 1 minus 2. So if I say summation sigma sign summation x equal to 1 to n fx, then it will be same as integration x equal to 1 to 3, sorry, x equal to minus 1 to 1, 1 to 3, 3 to 5, and last is n minus 2 to n. Total it will become minus 1 to n gx dx. Minus 1 to n gx dx is the net summation of all the 1 1 1 that falls in x equal to odd number. How much it will be? 1 by 2 is gx, 1 by 2 x. X is minus 1 to n, that is n minus minus 1, n plus 1 by 2. This is what we had got earlier also. If people remember, I believe 2 days back or 2 days back, when we were calculating right hand side area, we are taking now left hand side area. Means limit is x minus 2 to x. When we had taken x to x plus 2, then also it came as n plus 1 by 2 only. This time also it is coming n plus 1 by 2. Now let's compute the x is even number. So x is 2, 4, 6, 8, like so. And function over x is minus 1, minus 1, minus 1, minus 1, and so on. So fx at x equal to x is minus 1. And now if I do go over gx dx, gx is difference, that is 0. You start with 0, you will get 0. Now to have, now understandable, right? Fx equal to gx dx. Gx is dfx by dx, that is 0. 0 dx will come as 0. So we are getting result as 0, whereas we want minus 1. If I want minus 1, then we will start with the minus 1 itself. Then minus 1 integration will be minus x. From x minus 2 to x. Okay, let's do one thing. Okay, it is coming as same only. Rather than saying fx is minus 1, we will say 1 1, because we are adding minus 1 minus 1 minus 1 minus 1, where it is at x equal to 2 4 6 8. Leave the minus part. Let's add 1 1. At the end we will do minus in front of the full summation. So fx equal to 1 and gx dx x minus 2. So again it will come at x minus 2 only. If x starts from 2, then first sub area will be 2 minus 2 from here. So to find the generic equation, again integration will be x minus 2 to x dx dx, that will be 1. So it will be same as what we got, 1 by 2. So gx is 1 by 2. To get the final addition, we will start with 2 minus 2 to n, where n is along x axis, and that n is even number. Earlier in odd, n was odd number, n is even number. Now we will do the integration from 2 minus 2 to n, where n is even number. 2 minus 2 is 0, 0 to n, 1 by 2x, 1 by 2 dx, 1 by 2x, 0 to n by 2. Now n by 2, now we have to subtract because it is negative. So net will come at n plus 1 by 2 minus n by 2, where both n are different. Both n are different. The first n is odd number, last n is even number. But since we are calculating up to infinity, both n we can take the same. This is the most crucial part. Odd number summation is n plus 1 by 2, where n is odd number, minus n by 2, where n is even number. Since it is going to infinity, they will be same. So now we can solve it. N plus 1 by 2 minus n by 2, that will come as 1 by 2 only. This is the perfect solution for the Grandi series. It will come as 1 by 2. Now someone would say, forget the infinity. Consider the last number is 1. If last number is 1, then we will take n as odd number, n plus 1 by 2. In that manner, n by 2 in even number, n will be 1 less than the odd number, n minus 1 by 2. Now we can do n plus 1 by 2 minus n minus 1 by 2. That will come at 2 by 2, that is 1. This is what the expectation is. If last number is 1, that I know, not till infinity, last number is 1, that I know, it is not till infinity, then summation will be 1. If last number is minus 1, then if last number is minus 1, then n is even number. Then the odd number n will be 1 less than even number. So n plus 1 by 2 will become n minus 1 plus 1, n by 2 minus n by 2, 0. That is the expected one. This is this is typically called Grandi series. Okay, we will try another one. What is another one? If I have taken x equal to, we'll start again with the odd number and even number. X equal to 1, then we have taken area from x equal to 1 to x minus 1, x equal to minus 1, 2. Now, if it is x equal to 1, we will take it around it. If x equal to 1, then around it we will take. Means gap will be 2 only, but minus 1 to plus 1. What do you mean? Fx at x equal to limit x minus 1 to x plus 1 gx dx. Around any x, if I have fx, then minus 1 and then plus 1. This area strip will go and hit gx. So width is 2. Width must be 2. That is the required. So fx equal to 1 equal to limit x equal to minus 1, sorry, x equal to x minus 1 to x equal to x plus 1 gx dx, dx dx. Okay, if that is the case, then we will start again. Now we have fx equal to 1 equal to x minus 1 to x plus 1 gx dx. Dx dx equal to fx. If I start with 0, it will be 0. So we'll start with 1, that is x. X minus 1 to x plus 1, it will come as 2. Means more or less, we will try again 1 by 2. 1 by 2, limit x minus 1 to x plus 1 will come as 2 by 2. 1. Perfect. So here also fx is coming as 1 by 2 only. Anyway, to have the final summation, we will start if x equal to 1, then x minus 1 will start from 0, and for the nth one, n minus 1 to n plus 1, it will go up to n plus 1. So net summation of all odd x is limit x equal to 1 minus 1 to n plus 1, 0 to n plus 1, 1 by 2 dx, 1 by 2 into n plus 1. N plus 1 by 2, again it is coming n plus 1 by 2. Amazing, mind blowing. Okay, now let's try for the even number. For even number, again it will come at 1 by 2 only dx, the way we have done. Now what about limit? If I see the limit when x equal to 1, x equal to 2, it starts from 2. So 2 minus 1, and then if I take any n that is even, then n plus 1. So it will start, limit will be 2 minus 1 to n plus 1. Earlier it was 1 minus 1, it is 2 minus 1 now. So 1 to n, 1 to n, 1 by 2x, dx is 1 by 2, it will come as 1 by 2 into x, it will come as n plus 1, 1 to n plus 1, n plus 1 minus 1, that will come as n only. Amazing. So it will come as n by 2. Now we can settle it down, n plus 1 by 2 minus n by 2, where n by 2 is for even number and n is even. N plus 1 by 2, where n is odd. Someone can start the same story what we did. So if I go with for infinite, then both n will be same. Odd number n and even number n will be same because it is going to infinite, both will merge. In that manner, it will become n plus 1 by 2 minus n by 2. That will come as 1 by 2 1 if I take central area. Okay, if anyway, same kind of thing would same kind of logic, same kind of logic would arrive here also. So okay, now it would come to, I mean, we tried three ways. We if I have any x, then we tried x to x plus 2. We tried x to x minus 2. We tried x minus 1 to x plus 1. Three way. Now someone would say, will it be same if I take x minus half to x plus 1 and a half? Will it come the same reason? X minus half to x plus 1 and a half. Again width is 2 only. We'll try. Now x minus half to x plus 1 and a half dx. If I take gx as 1 by 2, the way we had taken 1 by 2, and then x plus 1 and a half minus half, that will come as 1 only. Perfect. Means gx will be 1 by 2 here also. For final integration, we will start with the x was 1. So 1 minus half to n plus 1 and a half. So it will come as 0.5 to n plus 1.5, 1 by 2 dx. 1 by 2 n plus 0.5 minus 0.5, n plus 1 by 2. I believe for odd even number also, it will come exactly same. N plus 1 by 2, there n by 2 means same. So the concept of solving any summation series through integral calculus is converting each vertical against a sub area. Each vertical in summation series, first draw a x-axis and then settle down x. Against each x, make a sub area, and sub area which belongs to a particular vertical, both will be same. Generalize it for x and then try to solve it. I believe this is amazing, mind blowing. We'll try to take another series, Grandi series, 1 by 2. No one would have expected, and this is indeed coming as 1 by 2 by the integral calculus also. This is what something that is not available in any of the book. Anyone can try. Please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.